Okay, students, we understand it regarding the message queue telemetry transfer. In that, it is designed for three different purposes. One is for remote connections, another is for limited bandwidth, another one is for small code footprint. We already understand it in the previous class. So next, we are going to understand some MQTT components. So what are the MQTT components? So first and foremost thing, the publishers. In MQTT, message queue telemetry transfer protocol, the publishers is one of the important component. So because using publisher is nothing but the sensor in IoT devices. So the sensors, there are different types of lightweight sensors are there to transfer the data. So whenever these are the publishers. So whenever somebody make the request to the message broker will keep all the requests in a queue to publish the service. Whoever wants that particular service, the MQTT broker will distribute that particular service. So we can say publishers is the one of the important component in MQTT protocol. Next, subscribers. Who is the subscribers? Okay, what are the applications that was interested for the proper sensor data? We already understand it. For example, a weather report can be accessed by uh, different types of organizations like weather forecasting organization and like military based organization both wants the sensor data. For example, what type of sensor data? Temperature, of humidity, what are the climate conditions. So this particular data can be uh, published to the publishers. That means publishers who publishes the lightweight sensors will publish the data. So who will subscribe? For example, a particular organization who wishes that particular data they want to get. So those are called as subscribers. In HTTP protocol, we know that the request response protocol. Similarly, here also we have publish subscribe, pub sub. Okay, means who subscribed, they will got published some sensor data in IoT devices. Through whom? Through broker. So brokers are nothing but MQTT brokers are the middleware middleware people or intermediate people, we can say intermediate component. MQTT component is an intermediate component. Here we understand that the connected publishers and subscribers, it is a broker. It creates it is a platform to connect both the publishers and the subscribers in a proper channel, because all the requests are making in a particular queue. Using this particular queue, they have to transfer the data. So that means they have to publish the data to the different places. So that is regarding MQTT components. So whenever some examinations this type of questions will be asked, then you have to please elaborately explain the answer, like what is a publisher, what is the task of the publisher, what is a subscriber, what is the task of the subscriber, and what is a MQTT brokers. So MQTT publishers, MQTT subscribers, and MQTT brokers. Broker is an intermediate between publisher and subscriber. So these three are very important components. These three are very important components in the MQTT. That means message queue telemetry transfer. Next, let me go for next thing. What are the methods? Okay, so whenever we are implementing the MQTT methods uh, to different types of programming, if I want to develop an Arduino programming, So I need a software like Arduino software. So we have different types of libraries that was provided. For example, MQTT library is also provided. We can download that particular library with our Arduino environment to for the purpose of data protocol. The data will be transferred. That is a data protocol. These data protocols can be implemented in Arduino programming whenever we are developing any IoT systems. So what are the methods? Please remember that whenever you are discussing regarding MQTT methods, we have different functions are there. The functions are given here: connect, disconnect, subscribe, unsubscribe, publish. These all are five different methods that was provided by MQTT, Message Queue Telemetry Transfer Library. So first we are going to understand connect. Connect is a method. It is used to establish a connection between one IoT device to another IoT device for the purpose of transferring the sensing information from one device to another device through MQTT broker. So what is a connect method? Whenever if you want to connect a device in a network, so connect is the predefined method in a MQTT library. Using this particular connect method only, we will connect to any particular device in a particular network or any other particular device, any other IoT device. Next, disconnect. So if you don't want to transfer the information, if I don't want to transfer the information from one IoT device to another IoT device, that may be any sensing data, any type of data. So I don't want, then I will disconnect. For example, my task was completed. I want to grab a weather data from the temperature sensor. So temperature is one of the MQTT client, one of the MQTT publisher. I subscribe to that particular temperature, then it immediately got the data. Then there is no connection established between the MQTT client and MQTT server. What I am saying is, MQTT server means it is trying to save the information to the MQTT client through message broker. So I will tell the message broker, please disconnect it because I don't want to use. I don't want to use this particular service. If I want, I will make the subscribe. I will give subscribe to you, then only you can publish, otherwise don't publish. For that particular purpose, the programmer is used to write the disconnect method. So disconnect is the method. It is used to disconnect two different IoT devices in a network using MQTT. So MQTT client will not be get the information from the MQTT server. And subscribe, we already discussed, the subscribe is the one of the important component. Subscribers is the one of the important component. What is subscribe here? Subscribe is the method. So generally, as a programmer, as any Arduino programmer want to implement this particular protocol in their projects, then he must use the subscribe and publish protocols. Subscribe protocol will give, subscribe method will leads to subscribing of any sensing information from the IoT devices in a network. So subscribe is the predefined method in MQTT library. It is used to gather the data, required data, through subscribe method only. If you not made a subscribe method, so then we cannot get the data, because once the subscribe method, using the subscribe method, you call for a certain data, the MQTT broker will knows that the service have to be provided to you. The request will be keep in a message queue, MQTT queue. Okay. Similarly, unsubscribe. Unsubscribe is also reciprocal of the subscribe. Unsubscribe is the predefined method. So, unfortunately, at the middle, or I don't want that particular service because I am trying to find the another service, then I don't want to continue. So then I will go for unsubscribe method. Unsubscribe means I am not getting any data from the IoT device or sensing device. Next, we have publish method. Publish is the predefined method in MQTT library. It is used to publish the data from one IoT device to another IoT device. That means the data will be published from one IoT device to another IoT device. So these all are MQTT methods. Please remember, please go for 5-sided links, that is connect, disconnect, subscribe, unsubscribe, publish. Whenever they are giving a long answer for MQTT, you have to explain each and everything regarding MQTT, like what are the components of the MQTT, what are the methods of MQTT. Now we discussed these all things. These all are the predefined methods we can find from internet. That means this library will be finded, because whenever we are developing the any project, IoT project in Arduino, we have lots of libraries that was available in different clouds. We can easily download it and we can use in our projects. Similarly, these all are the predefined methods related to MQTT. Okay. So now, what is the working process of MQTT? If you go for MQTT message queue, how this particular, see here, there is a temperature sensor. Temperature sensor is the publisher here, and the subscribers are laptop and mobile device. I have two different devices like a laptop and mobile. So then I want to get the data from the temperature sensor. Okay, DHT sensor, dynamic temperature sensor. Okay, I want to get the data from my laptop. I want to get the temperature right now. What is the temperature right now? Similarly, my mobile device is also wants the same data. Then what happens? See here, there is a message broker. He will be intermediate between this publisher and subscriber. Publisher and subscriber. So laptop is the one of the MQTT client. Mobile device is the another MQTT client. So these two devices makes subscribe to the MQTT broker. MQTT broker is an intermediate software. So it stores all the subscriptions, all the requests in a queue, message queue. So whenever laptop wants the temperature, right, what is the present temperature, then he subscribed to MQTT broker first. Then MQTT broker will keep the that particular request in a queue. Similarly, mobile device subscribe to MQTT broker, then MQTT broker keep that particular request in the message queue. So after that, so the message broker, MQTT broker, will connect to the subscriber, publisher. The publisher is the temperature sensor. The temperature sensor will publish the data, for example 30 degrees centigrade. What is the current current centigrades? 30 degrees centigrade will be published. The published information will be gathered by MQTT broker, that may be also called as middle level software. So then it will be according to the queue. We know that what is a queue, first in first out. Based on that, who make the request for the subscription, he will, message broker will publish the data. Okay, every time it is going to publish the current situation. What is the current situation means what is the current temperature, that will be published. If the temperature was changed, that will be changed and displayed to the particular clients. Okay, so whenever you are explaining the concept, please draw the diagram and clearly explain the concept. This is message queue telemetry transfers working process. Next, so how the communication is going to be done? How the communication is going to be done? The protocol uses a publish subscribe architecture, similarly like HTTP uses request response. I already tell so many times. Whenever we are using web applications uses the HTTP request, HTTP response. Okay, but whenever we are considering in MQTT, we have to use the publish subscribe protocol, publish subscribe architecture we are using. The communication will be established through publish subscribe methods. Publish subscribe is event driven and enables messages to publish to the clients. What is event driven here? Event driven means some action will be performed automatically. Some action will be performed. For example, in previous slide, we understand that the temperature sensor will publishes the exact temperature, whatever temperature that will be given to the MQTT clients based on the environmental situations. So similarly, event driven means some action is automatically performing, so that enables the messages based on publish subscribes. The central communication point is MQTT broker, which is in charge of dispatching all messages between senders and rightful receivers. So we already know that MQTT broker is the intermediate person. He will receive all the requests and keep in a MQTT queue, a message queue. So and then based on the requests and in order, in sequential order, it is going to be transfers. It is going to be published the information according to the request numbers by the message broker. Next, each client that publishes a message to the broker includes a topic into the message. The topic is the routing information from the broker. So generally here in this last point, each client that publishes a message to a broker, every time the message, that means making a request, that means subscribe to that particular service. It is asking, I want weather service, I want smoke service, like this. I want different types of services. The MQTT clients makes the request, so the request will be keep in a message queue by the message queue broker, and then based on whatever routing information I already shown to you, whether what is the quality of service, which type of data have to be published. Every time the car speed, we already understand it in the previous video, the car speed can be identified by the clients, MQTT clients, anywhere through servers. The server is a middleware software that is also known as MQTT broker. We already discussed, we already understand some video, very good video in previous class. And next, each client that wants to receive messages, subscribers to a certain topic, and the broker delivers all the messages with the matching topic to the client. That means every time each client, that may be laptop, mobile, desktop, farm top, etc., there are different types of IoT devices, wants a particular service, that means a temperature, so wants to receive the messages, they have to subscribe to that particular topic, that means that particular service. Then the message broker will deliver that particular messages based on the topic, because one client wants one type of service, another client wants another type of service. Message broker will fix which type of service, based on that only the response will be given. Therefore, the client don't have to know each other. So that's why the clients don't know he is making request and he is making request. That means the IoT devices are making request. This IoT device don't know this IoT device making request. This IoT device don't know this IoT device making request. Okay. The architecture enables highly scalable solutions without dependencies between the data producers and the data consumers. So mainly this complete architecture consisting of MQTT client, MQTT server, MQTT broker. So MQTT broker is the middleware operator, or he is the in charge for dispatching all the information to the respected clients. We know that the architecture gives the exact scalable solutions to each and every consumers. Okay.